Hello, everyone. My name is David Stevens. I'm the Industrial Applications Manager for Trotec Laser. And today, I'm going to show you the exciting process of engraving photographs onto different substrates using your Trotec laser systems. Laser processing photos is one of the most exciting things that you can do, and also potentially profitable that you can do with your laser systems. However, creating a satisfactory technique can be a time consuming trial and error process if not done correctly. Fortunately, it is possible to produce consistent, good engravings giving some basic knowledge of the process and access to some different imaging softwares. The outline of this seminar is going to include acquiring an image, quality, resolution, and digital image formats, photo editing softwares, job control photo features and options, photo rendering softwares, different lenses and optics, selecting quality materials for processing photographs, selecting the correct parameters, as well as a final photo engraving checklist. Digital photography is the first step when engraving quality imagery. Some digital images are better than others for engraving. An understanding of quality digital photography is the first step towards producing quality engraving. Brightness, contrast, focus, detail, and definition are key. Here are a few examples of some poor photography that is going to produce, in turn, a poor engraving quality. To the left here is lighting issues, poor substrate. You're not going to see too much detail. So if you engrave this same type of photograph, you're going to receive the same type of result onto that material. It does not matter if you're engraving a piece of material and if you have a poor photograph, such as focus issues, exposures issues, too much lighting, not enough lighting, those inept qualities and or problems are going to be transmitted into the engraving process. So the first step is truly understanding what is a good photograph? How do you get a good photograph? What is a bad photograph and the difference between the two? We're going to go through each one of these different capabilities, what to look for, what not to look for, so that you can get the best results with your engraving. The first step is, if you're taking your own photography, is to use quality photography equipment. It is tempting to, of course, use the old flip phone or a low grade, low lighting, poor quality cell phone for your imagery. But of course, the better your camera quality, the better the image quality. And that better image quality produces better engraving quality. Better cameras tend to have a better sensitivity of light versus, say, your cell phone. They have quicker and faster shutter and focus speeds. The difference to, or the ability to use different lenses. Those lenses are going to give you different depths of fields. They're going to capture more light. They're going to give you the ability to take photos from much further away versus, say, zooming into a digital image where you're just zooming into those pixels that aren't already there. And they generally are going to give you full control over the depth of field of those images. And so if you're taking the photo from the inception, the quality of the equipment and photography equipment can be a dramatic improvement on your finished engraving if you use the correct equipment. Here's a good example. The camera difference taking with a cell phone and then zoomed in and cropped to that cell phone on a low grade camera there showing to the left of the same image. And then a high grade SLR camera taken of that same image also cropped and zoomed in. As you can see every individual hair and follicle and reflection of the eye of the animals, in the dog and cat in this case, on the right side of the screen versus the low grade. From a distance or online, it may look just fine. You may also see this same image or download it from a Facebook page or something like that. They tend to reduce the quality when uploaded to a social media site. So in this case, the original image from the original camera can be key in producing the best possible result in the image or on that image. And that, of course, transmits into the best quality. If you don't have the ability to take photographs, or you don't want to take photographs and maybe you just need a certain image, there are many different ways to acquire high quality professional grade images Royalty-free stock image sites are a great solution for extremely high image quality, and they're very affordable. Typically, it can be, $10 to $15 a month for, say, 5 to 10 images a month, or you can pay a few dollars each per image. These image sites allow you to search for that exact image, that exact location. If you need a photo of a city or a person, or just an example to reference against towards your own photography to know if you're doing a good job or not, you can go on to some of these sites, and I've outlined a few of the more popular. Dreamstime has over 100 million images. Shutterstock has over 200 million images. Adobe Stock is a newer one, over 50 million, and then it of course automatically embeds into your Photoshop. And then last is the one that I've used also is iStock Images. These image sites a lot of times also have many free images, and so you can go on and download them. The benefit is they are copyright and royalty free, so you don't have any possibility of lawsuits or litigations by using something that maybe you find online. They're also guaranteed to be an extremely high quality, meaning that the depth of field, the quality, they're taken with the top end high end cameras, and the sites will not allow the photos to come in to the site. And so basically, the way that it works is photographers, even yourself, or anybody that is good at photography, can sell their images to these sites. The sites then review the photos and then upload them. And if you want, you can make some extra money by selling your images to it. Every time someone downloads your image, you get a percentage. Because of that, these sites produce hundreds of millions of different types of images that are constantly growing. So it is a great resource for high quality, premium grade graphics for a very low cost, and if not free. And like I know Dreamstime has many free images. You just have to sign up usually to get those. So take advantage of these. If you're not sure what kind of quality levels, go onto these sites, download them, and then use them as reference for your engraving so that you start out with a good quality, high resolution image, non-rendered, or it's not been converted down to a lower resolution through like a social media site. These are the best possible quality that you can get, guaranteed, because that's what these sites actually do. Resolution is everything and quality is everything. And here's a good example of where resolutions can kind of show you. And sometimes on like websites and online and stuff like that, it's difficult to see the difference in resolution until you really kind of understand it. Resolution, or DPI, or dots per inch, are basically the amount of pixels or dot density in a square inch of digital data. So example, a 10 DPI image shown above here will have 10 dots down and 10 dots along, basically. And so you could literally count 10 by 10, producing in every square inch is 100 total dots. And each one of those dots you can pretty much identify as a laser pulse. So the more dots that you have, the better the quality. The more the quality, the better the image resolution comes. So example, we go from 10 DPI to 300 DPI, which is the max I have here. And that same 1 inch by 1 inch sample has 90,000 dots on that same exact 1 inch by 1 inch location. And because there's more dots in that, the resolution is better. You can zoom into that. And this is what I mean by resolution and quality. Most images and some images can go much higher than that. You can go up to thousands of DPI should you want. The laser likes anything, the higher you can get, the better. And if you enlarge a photograph, your dots per inch are actually being stretched out. You're not actually adding resolution. There's no way to really add resolution after that original image was taken. Or if that an original image was converted to a different format, say through a social media outlet or something like that, they actually change the resolution so that it doesn't use as much space on these websites. This is why when you download graphics off online, a lot of times they will be a very low size or a low DPI and resolution. Understanding the quality of the original graphic combined with the resolution that the image was taken. This is why the original camera resolution, or DPI, is very important versus something that you have pulled from another source. Now, file formats can also make a difference. You typically have different file formats out there, some of the more common compressed formats, and there's a difference between a compressed and a non-compressed formats. Compressed formats, the most common are your GIF, your .gif, your .png, and your .jpeg. There's many others as well as this, but these are some of the more common. Compressed formats basically are a compressed down so that the overall file itself is much smaller in size. They are typically compressed sometimes as much as 10-to-1 compression over non-compression formats, making them far more manageable. A lot of cameras take the original photograph in a compressed format. So you get a much smaller image size. They're great for viewable from the internet. They still use millions of colors, and they're perfect for most images. But the one thing most people don't understand is if a photo is originally taken as, say, for example, a JPEG, it cannot be converted to a non-compressed format at a later date. So that quality level that you may get as a JPEG or a PNG format will stay that format forever. You can't get it back. Now, a non-compressed format, the drawback is they are much, much larger in size. And so typically they're very difficult to email, they're difficult to place online, and so they require a lot more space. But the difference is formats like BMP and .tiff or TIFF formats and bitmap formats are the most common. Again, there are many others. These uncompressed formats are far larger in size and they require more space to store, but they retain 100% of that pixel data and colors, making them best for editing and enhancing at a later date. They are the most high quality. They're easy to edit to change. No image loss through the process. And these type of images can be then, once they've zoomed in, edited, cropped, whatever you want to do, can then be compressed to a compressed format, making them smaller. So if you're originally taking your photographs in a non-compressed, or if you go to the sites that you download the graphics itself, you can typically download them in a bitmap or TIFF format. And then you can edit them, modify them, and then resave them as a compressed format, say as a JPEG, for example. And then you can use that as needed. But the original editing capabilities is retained by converting them or having all that image data. And this is mostly when printing or sizing or scaling or cropping or really zooming into a graphic where the compression can actually take, and the way that compression works is it basically says, okay, these colors are really, really close to each other, so let's all make them one color, so it eats up less data in the file. Non-compressed image don't do that. Even though the color may be well beyond the human's eye of sight, they don't do that. Each pixel is identified as its own data. So therefore, when you enhance or bring out the difference within each one of these in the file, some of those nuances can be enhanced and modified using photo editing software. And that's really the difference between the two formats. Not saying anyone's better than the worst. Really depends on what you're doing with it. Most of the time, a JPEG is just fine, or a compressed image. But if you are enhancing, modifying, or if you want something in a very, very large print or engraving, you want to try to maintain the non-compressed graphic for that. Image size is the next aspect. You can have a compressed image or a non-compressed image, but if the image was originally shot or taken as a low resolution, meaning the amount of photo resolution from the camera itself, just because you have an uncompressed image doesn't mean the resolution is there to support it. So here's a chart that I've come up with that kind of tells you the size of the graphic. So when you look at the size of a graphic online, it typically comes in kilobytes, known as KB, which is basically how many thousands of pixels is in your graphic. Or it'll say MB, which is megabyte. Megabyte is millions of pixels in the graphic. And then GB, which is gigabyte, would show you basically how many billions of pixels in the image. So the more or the larger the size of the graphic that you download, typically means the higher the amount of pixels that are in the graphic itself. It's a good identification on whether or not your graphic is of high enough quality. And here's a chart that kind of gives you a guideline that says if I'm engraving a 4x6 piece of substrate, I need that image to be about 2 megapixels in order to get decent engraving quality out of that. And the ideal image size in a compressed graphic, not a non-compressed graphic, so this would be a JPEG, would be about 2.8 megabyte. So if you're downloading a file and you see it as 500 kilobyte and you want to engrave it 5 by 7, your quality is not going to be up to par when it comes to engraving that size. So kind of use this chart as a general guideline of how large your file needs to be to get optimal engraving quality out of the finished graphic, and understand what size of image that you're downloading is going to transmit into what size of engraving size you're going to actually do. Because quality is everything. Quality image equals quality engraving. Here's a great example of a very high quality TIFF resolution graphic that was engraved on a 12 by or 24 by 12 engraving onto solid cherry wood. I would not be able to see all the nuances and detail that you see in this engraving if that original graphic didn't have the pixel data or density to be able to do that. This was an extremely high resolution, uncompressed graphic, which then transmitted into an extremely high resolution, high quality engraving. So look for the best images with not only the resolution, but the images also has high contrast, great lighting, sharp and clear details. The resolution is also there, and it has a feature which I personally like and have found that work extremely well with engraving, which is a high dynamic range, known as HDR. HDR is a great format or type of photography to look for if you're just getting into photo engraving, because the dynamic range kind of eliminates the lights and the darks. And here's some examples of what HDR is. So if you look for an HDR image versus a standard dynamic range image, high dynamic range is a dynamic range higher than what's considered as your standard. HDR is ideal for laser engraving because it's sharper, it's got those higher contrasted builds in it. There's far less dark areas and bright areas due to the way the photo was originally created. Now, you can't just take any image and make it an HDR image. HDR images are taken with cameras. Even your typical mobile phones have an HDR mode these days. And the way an HDR photo is actually taken, and it's usually taken from the photo itself, but here's how it's actually taken. One photo is not taken when an HDR photo is taken. Multiple photos at different exposures are taken, and then the software within the camera or photo software like Photoshop can then do this as well. But it basically takes the best components of each exposure level and puts it together. So here's an example of 5 different photos. The first 5 is a very dark, medium, lighter, and then overexposed graphic. And then the final one in the lower right-hand corner here is the best components or the best part of each one of those exposures put together, so that in this case, you actually can see in the dark because each exposure component is then put together using onboard software of the camera to give you that best dynamic range. You're not seeing the dark areas, you're not seeing any of the bright white areas, you're getting an almost animated look onto the graphic. And when it comes to laser processing materials, the laser loves this capability. So looking at this type of graphic, especially for those novices or someone that is not into photo engraving, this is the best type of image to look for to start, to really give you a good idea of what the best type of image is going to look like, and kind of train your brain to give yourself the best understanding of how to create what the best image quality is going to look like on the screen so that it transmits into the best engraving. Now, just because you have a good HDR image and everything like that, there are still needs for your photo editing softwares. Photo editing software is going to give you a lot of ability, and without it, it really does limit your ability to engrave quality images, unless you just deal with all high quality images, or if you go to your Dreams Time or Shutterstock sites all the time. But even those sites, a lot of times I want the ability to resize the graphic, change the resolution, sharp my edges, adjust brightness, contrast, the sharpness level, shadow, highlight corrections, adding lighting effects, textures, dropping out backgrounds. All these can be done in photo editing softwares. You can go with Adobe Photoshop, which is kind of the premier out there, but it costs a fortune. It's also highly complex, where there are a lot of other solutions out there, including Adobe Photoshop Elements, which is only $69 and still in the industry is the best basic photo editing software out there. Corel Photo Paint or Paint Shop Pro is also a good solution, and it typically comes with the Corel Suite package. Another one out there is very affordable and also ranked extremely high is your Affinity Photo. Any one of these photo editing softwares is highly recommended if you're just starting or getting into photographs. The reason is you need the ability to process changes to the photos and make those changes into those photos. And so that you can take, say, a poorly scanned image and turn it into this. This is something Photoshop is able to do. They're able to actually add color into it when the original file wasn't taken in color. Not that we would need that for engraving, but it enhances certain areas. It fixes blemish repair, and they're very easy to do, especially on the Elements version of Photoshop. And there's a lot of online tutorials and YouTube videos that give you a quick and easy understanding to do that. And I'm going to show you a few examples using Photoshop here. This is Photoshop taking an image. And what we're going to do here is I'm going to take an image that was overexposed. It's a good quality. It's a compressed JPEG image, but the original image was taken in the bright sunlight and the image was overexposed. If I engrave this, it's going to look okay. But in this case, I want the ability to bring out some of those colors because most of them are still there. And so any photo editing software, I can adjust the levels or your gamma correction within the graphic just by going to, in this case, levels, and then adjusting some slider bars to kind of bring some of those middle tones back up. And as you can see, as I slide left to right, I'm able to bring some of these colors and some of those details back out of the graphic. And because of this, the engraving quality is going to be considerably better. And so what I'm going to do here is I'm going to take this graphic and I'm going to show you the process of the before and after, and I'm going to engrave it, the before version and the after version side by side on the same piece of material utilizing the same laser system just to show you the difference that a simple Photoshop or photo editing software adjustment can do. So this is the same image engraved on a piece of cherry wood. The image that you're seeing engraving on the left here is the photo edited version, and the image that you're seeing engraving in time lapse on the right is the non-photo editing version of it. So as you can see the difference, simple photo editing software has given me the ability to very, very quickly bring out some of those details. And as you saw that, both of these samples were engraved with the exact same settings at the same time on the same piece of material. So before Photoshop, we got a very similar look of the original graphic. Kind of what you see is what you get. After Photoshop, you can see all those minute details, the trees in the backgrounds, the faces have come out, the intricacies of the little dogs and the little girl's face in this really nice high grade photograph. Now the pixel data and the quality of the photo was there. It was just taken with a little bit too much lighting. Typically, poor photographers do this all the time, but that doesn't mean that that image can't be saved. And this is a good example of how that can be done. Now, if you have a photograph that maybe you need some blemish repair, that photo editing is also that capability. Whether it's a scanned image from an old photo that you scanned, or if it's just an image to where, something like this, where I have an image that was taken here. And there's some skin abrasions and some difficulties on it. There's simple features within Photoshop or for your photo editing that allow these type of things to be fixed, whether this is a scratch on the photo from a scan or if it's not. I can use features like the spot healing tool here. It looks like a band-aid, and that's basically what it does. I'm able to go over a blemish on a photograph, and it blends everything from that surrounding area back into that centralized location, giving me a almost flawless repair of that graphic. And this can be done with any type of blemish in this case. As you can see, just a simple click with this in this case, it's called the healing brush tool. It's also called the spot healing tool. But there's a lot of different of them. But any of these little blemishes, again, no matter what they may be, simple adjustment, just a click of a mouse button, and I'm able to very quickly take this photograph and remove these blemishes or wounds or repair any little component or scratch in that photograph. I will typically zoom in, I will zoom out. And this way you can get kind of a good consensus of how well I did. And so very, very quickly, you just saw a live view of the finished result of that finished graphic itself. So what I did is I took it just very quickly, I removed all those little blemishes, the pesky little skin abrasions, so that you can see it there before and then after, all cleaned up. This little tool is very, very beneficial for cleaning up any of those little problems, little hiccups, and it works very well. And then, of course, you can engrave that graphic. In this case, is on a nice piece of stone, rendered it through a photo rendering software, and then engraved it onto a piece of stone here. That stone now doesn't have these little blemishes, and so you've taken a photograph, improved the improvement of it, and then we went ahead and engraved it onto a nice piece of 4x6 marble in this case, so that those little blemishes don't show up on that. And we've taken an image that may need a little bit of an adjustment, and fix those very, very quickly. You can't do that, sometimes in life it's easy to do that. Makeup will cover it up, but sometimes it's a quicker and easier way to do that utilizing photo editing software. So there you go, before and after Photoshop. Engrave it, and then the finished engraving onto marble for the finished results. So these are all different ways to clean up photographs. Now, really understanding, and you're kind of getting a sense right now that just because you want to engrave a photograph, there's a lot more involved with it. And you don't necessarily have to go through any of these steps. If you've got a really good photograph, you don't want to use any photo software. You just want to hit print and send it to the laser. Well, out of job control, we have many of our different algorithms from Trotec that are going to allow you to do that. So job control has a lot of photo capabilities built directly into it. What that means is we have the ability to take just a color photograph, send it to the laser directly, and then turn on different photo modes. We have ordered dithering modes, which allow the ordered raster structure. So basically, it converts it to a dot pattern. So the laser automatically converts any photograph or any gradient graphic that you put on the screen into an engraving. This is done automatically through our driver just by turning on to one of these different modes within the driver. So you don't have to use photo editing software. You don't have to have the best quality image. You can engrave directly any image of any resolution and any quality directly to job control and still get an adequate result. Of course, your better quality images and your better tone range and the better sharpness of the graphic is still going to produce a better engraving in this case. And so I still recommend producing or looking for a high quality graphic before you send it to the laser. But the ability to actually use the photo conversions right in job control basically take the difficulties out of really understanding. And we have 4 different adjustments within job control. We have your order dithering, which basically order your raster structure, producing points that are placed into a vertical raster structure and differ from a different size depending on the gray tail. So more dots and more or less dots for dark areas, less dots for light areas. We also have an air diffusion modes, which are chaotic or random dot placements that kind of change the dots, basically converting your graphic to a black and white dot pattern to create a little more detail and accuracy. And these 4 results will allow you to take just a generalized photo. So here's a black and white photo that I have. All I did is send that, or I cropped and sized it first, and then I ran it through my design software, Corel or Illustrator. I hit print right from my grayscale graphic. I then told it which different mode I wanted to run. So here is an example of the same photo engraved directly through job control, utilizing the order dithering, Jarvis mode, Floyd Stuckenberg, and the Stucky photo filters. These are built into job control. And I'm going to show you the process of doing this by utilizing the photo optimized process from the Trotec job control driver. So when you actually send a job, you can actually turn photo optimized on, and then we can control the type of halftone to get the different photos. And so here's a quick video that is going to show you the process of the raster algorithms using the job control. So job control photo rastering algorithms are built directly in. And to do that and to use them, what I'm going to do is I'm just going to open up my graphic or import my graphic directly into whatever design software I'm using. It really doesn't matter at this point. You can run from Microsoft Word, or you can run it right out of Photoshop or Corel Photo Paint and then send it right to the laser. Ideally, you want to use a software to crop it or size it down to the size of the graphic. In this case, I've got a 2 by 3.5, which is a business card size, and I'm going to engrave it onto a piece of black anodized aluminum. So all I've done is open up or import my graphic that's already been sized. Then I'm going to select my Trotec engraver from my printer list, and I'm going to go into preferences so that I can access my job control parameters. Within my job control parameters, in this case, I'm going to select the material I'm going to engrave on. In this case, it's going to be metal and anodized aluminum, which is already set there. And then I'm going to go into my process options shown here, turn on photo optimized, and then I'm going to identify which photo mode I'm going to use. You got order dithering, Stucky, Jarvis, and these are the different modes we're going to do. And then since it's an inverted state material, meaning the engraving is going to turn white, I'm going to select the invert button, select job control, and then print this image, this gradient graphic to the laser. This could also be in color; it wouldn't matter. The process is the same. Gradients kind of easier to identify what you're going to see. Then I'm going to open up my job control software, and that photo should be sent over to the job control software. I'm going to grab that graphic and I'm going to bring it over to my job control page. You can see here it's automatically converted it. It's inverted it because I select the invert button, and then it's pixelated it into a dot pattern. And so this is the ordered dithering feature, which is the dot pattern, basically, kind of like an old newspaper print. And so it's adding more dots for lighter areas in this case and less dots for darker areas to give you that half-toned looking photograph onto a piece of anodized aluminum. And as you can see, it does a great job. So we're able to, in this case was a time lapse, I was able to take this original image and I was able to convert it onto a very small tag. That's why it looks a little pixelated at this point, onto this anodized aluminum. Here's that same image using the Jarvis filter. Same image using the Floyd Steinberg filter. And then lastly, the same image using the Stucky filter. And then here's all four of them combined, all utilizing job control as the base, directly engraving that photo onto these materials. So this process can be done very quickly and easily just by opening up your image, sending it to the laser, selecting the type of filter that you want, and personal preference. Some people like one versus the other. If the material has the need to be engraved onto a material that's going to turn lighter, you want to invert the image. If it's going to engrave darker, like a piece of wood, you would not invert the image. And so you need to remember to do that if you're depending on the material you're going to engrave it on. In addition to all this software and stuff like that, there are other things on the laser you need to keep in mind. What lens you're using. Lenses are huge. It's kind of like lenses are the ability to produce different details onto different substrates. So if you want the best quality photo, there's a lot involved, as we're kind of discussing with this seminar. You need the correct lens in order to get the best quality photograph. And so here's a good example. It kind of shows you some of the more common lenses, the 1.5, 2, 2.5, and 4. We also offer other ones for the fiber lasers and stuff like that. As you can see, lots of different choices of lens. Most laser machines come with one, maybe two, depending on what you ordered. Most machines tend to have a kind of a standard is the 2.0 lens, which is kind of good for your cutting, your engraving. It's optimized for specific details. It's not necessarily the best for engraving, but it's also good for cutting, a little bit of tolerance, and that's really the difference. As you go up in different lenses, You have the ability to have better tolerance as you go further away. But the drawback is the longer your focal length, the lower your quality. And here's a good example. So what I've done is I've taken a 1.5, 2, 2.5, and a 4-inch lens, and I've engraved the same graphic onto the same anodized aluminum piece of material with each lens. And as you can see here, the quality and sharpness and brightness is improved as the spot size go down. So this is a good example where the smallest intricate detailed spot size. So a 1.5-inch lens has a beam diameter or spot size in or around 3 thousandths of an inch, which is insanely small. A 2.0-inch lens has a spot size of about 5 thousandths of an inch, and it still produced a great photograph, but as you can see, it's not quite as bright. And if you really zoom in, you can't see some of those details start to go because your spot is a little larger. And even if you have the pixel density and detail, you can't achieve that. And so different lenses can make a difference. Followed by the 2.5 and, of course, the 4, which is, of course, the porous lens, because our spot size is 12 thousandths of an inch versus 7 thousandths of an inch on the 2.5, 5 thousandths of an inch on the 2-inch lens, and then 3 thousandths of an inch on the 1.5-inch lens. Now, you can have the right lenses, you can have the right photo, you can have the right process, the settings, everything down, the right enhancements with running your photo software. But when it comes down to engraving photographs when it comes down to engraving photographs on a laser system, the biggest and one of the most important things is using photo-friendly engraving materials. Selected materials can dramatically impact the overall quality of any laser processed photos. So what this means is you want to avoid materials that produce a lot of patterns and grains because laser technology is reactionary, meaning the engraving into the surface of the material, whether it's a photograph, whether it's text, whether it's just imagery, will produce patterns and grains. And so choosing a material that has the right amount of detail, can produce enough contrast into that material, can produce a small enough pulse into the material and actually achieve those details is imperative to get a great photograph. Here's a list of some of the more common materials for engraving photographs. Now, that doesn't mean you can't engrave photos on other materials. It just means that some materials will produce less quality when it comes to etching into those materials. So materials like your acrylics, Troglass acrylic is the brand name of Trotex acrylic, but you can use painted acrylic, Alumimark materials, anodized aluminum, the metals, painted metals, glass, leather, stone, stainless steel, Trolleys plastics, or any of your microsurface plastics. Stone also works extremely well, but the darker the stone, the higher the contrast. Natural stone tends to turn white when engraved, so if it's a white or a grayish stone, the contrast is not going to be there. Laser tile, the type of like ceramic tile made for laser. You can go to lasertile.com to get that. Light color woods. You want to stay away from your dark woods, your walnuts and your mahoganies and stuff that have less contrast. Lighter woods are going to produce a dark effect into the wood, and darker woods are going to produce a dark effect in the wood, producing less contrast, so therefore photos won't stand out as much. Again, that does not mean they won't work. It just means that they may not produce the best effect. So if you are looking to do a photograph into a material, stick with the materials that are known to produce good photographs at first. This way your testing kind of produces the best possible results without throwing in a curve by not knowing the reaction to a type of material. So anodized aluminum is ideal. Materials that don't produce, glass is actually one of the more difficult on this list. Woods are a little more difficult because they don't react as well. Leather is a little more difficult, where materials like your acrylics, anodized aluminum, painted acrylics, and your Alumimark, your Trolleys plastics, your microsurface plastics, natural stone work the best. Laser tile also works as best because they're designed for laser engraving. So play with the material, understand the different material, run a test on the material to see how good of contrast that you're able to achieve onto that material before you actually do a photograph onto it. Or check with a professional in our applications department, with your sales representative, our support, and kind of find out. Or do a Google search or go on Pinterest and look for other maybe examples of engraved photos on materials so that you can find something similar to work with. So material is very important. It's as important as the type of photo. It's as important as the quality of photo, the type of software you're using. Each one of these different components are necessary to get that high quality premium grade photograph when it's engraved. When it comes to also engraving that, if you have good material, we have good setups, we've got everything else like that. The laser systems also give you the ability to engrave at different resolutions. Laser systems can be as low as 100 dpi, can go all the way up to 1000 dpi. And this is different than the digital dpi that I showed you earlier of pixel resolution. This is the amount of laser passes or dots or the overlap of the laser itself. So at, for example, 500 dpi, the laser actually moves the head back and forth 500 passes or lines per inch as it engraves. Most laser systems can range between 100 and 1,000. Some even go beyond that. But this will determine the kind of quality you can get. Now, the right lens can make a difference whether or not you can see this quality. So, and also beyond that is not only the lens, the material. Some materials react better to a smaller spot size because it can actually achieve it. For example, anodized aluminum can easily be engraved at 600 to 1000 dpi because the raster or the points or the every time that laser fires into the material and it reacts into the material can actually be seen from one to another at these high resolutions. Where wood and glass, 3 to 500 is going to be your range because those materials don't react as well with a laser pulse. The engraving quality is a little coarser from some of the samples I've showed you so far. Acrylics and laminates can be 5 and 600. And so playing around with different resolutions and kind of understanding that depending on the material, even if you have a good photograph, the different resolutions you can do. And this doesn't matter what your power settings are, doesn't matter how good your photograph is. The difference is whether or not the material can handle the high resolutions. If you go too high of resolution on some materials, it's just going to take longer because that laser is taking back and forth passes. For example, a file that takes 1 minute on at 500 dpi would take 2 minutes at 1000 dpi because you're taking twice as many back and forth strokes with the laser. And sometimes if you can't achieve any detail by going that, you're just wasting time. So play around with it. I suggest that if you're not familiar with DPI, you can take the same photograph and you can engrave it at 300, then engrave it again at 5, and then at 600, and then at 1000. So you can really see the difference between the same photo on the same material and kind of see where the difference is, if there is any improvement, and kind of get a sense of what is the best resolution for it. And use these guidelines of the material that I have here on this sheet or on this slide to kind of show you a baseline of that as well. Now, resolution is just one of the settings. The other settings are your material settings. And so to find the best material settings, most laser systems, including Trotec, have presets. So you can select the setting for woods and types of woods and acrylics and anodize, etc. And all these different materials are set, but the best setting for a photograph may not be the best setting in the database. And so a database setting is good for your text and logos and gradients and graphics and stuff like that. But I find that a lot of times photographs require a little less power than your typical engraving text, logos, and graphics. If you run at the same power settings for most of the materials, photographs tend to be a little bit washed out. They don't look good. And so what I recommend is a little bit of trial and error. And I have created this color wheel, if you want, or a profile test for mapping power settings. This is a great little tool for dialing in power settings on a material to kind of find out where that material reaction lies. You can also do a little bit of trial and error, running a photo, playing with power, or bringing the speed up or down. And that's the only two things you really need to adjust. If your power on something like wood is 100%, and you need a little darker look into your photo, then you would want to slow it down. If you're at 100% speed and it's still too much, you may need to drop your power. So those are really the two power settings that need to be adjusted in order to get the best results. And I have an example here to kind of show you. I've taken this wheel and I have all 16 colors, and by controlling the different color, I can go into the Trotec driver and I can actually assign a different power setting to each one of these colors. And so by designing a simple file, it allows me to engrave all these different colors. In this case, I'm going to change the speed profile. So what I've done here is I have a different speeds at in this case 100% speed, and I'm adjusting through different percentages of power actually. And so I've seen moderate differences or moderate improvements on this. And so I can now look at it and say, okay, at 100% speed, at whatever power, I get this effect. It didn't make a lot of effect into wood as you saw in that previous portion. And so now I'm going to run the same one, but instead of adjusting the power, I'm going to adjust the speed. So leaving the power now at 100%. I'm now going to adjust the speed to different percentages. So there's 20, 25, 30, 35, 40, etc. as we go up. So this is actually telling me at 100% power, and I adjust a different speed, how much reaction I'm getting into the material maple wood in this case. And I now have a color mapping wheel that I can set aside for this material and look at it any time and kind of determine how dark at what percentage of speed I'm going to get. And so this kind of gives me a benchmark or a recipe wheel, if you will, to get the best effect into it. And so I can look at this on this material. And if I were to make one of these for each of the materials that I commonly engraved, I now have a full spectrum. It may not be the setting that's pre-programmed for you because that has been picked based on an average of both power and speed for the majority of materials. But maybe you want to go beyond that, or maybe you want to adjust it for a photograph. And so making a little wheel like this, and I've made it easy for you. You can scan this QR code and it'll download either the PDF or CorelDRAW file of this exact file format, so you can make your own. This way you can modify it, you can change the name of the material, you can play around with the different settings just by changing the percentages on here, and you can draw and make your own so that you can have these sitting next to you to really have a visual representation of the entire spectrum of reaction towards a specific material, not just the preset. This is a big advantage of knowing how your laser is responding. Every laser is a little bit different depending on the lens, the material you're using, and your overall expectations or the look that you want to achieve, because everyone's different. So understanding power setting, you can play with your power settings up and down. You really want to make sure your photo is a good quality. You want to use photo editing software if you want a good photograph, HDR photographs. You want to go through all the different processes and using the right material, the right lens, the right power settings, and when you get the right formula together. And I know it seems complicated. There's a lot of different scenarios and different possibilities. Most photos don't require most of these steps. I have created a checklist here to kind of go through of what you need to do. So, select the photo for engraving, making sure that it's a good quality. Stick with an HDR if you want the best possible photograph. Edit, enhance, crop, or repair if needed. If it's a good photograph, you think it's great, it's got good contrast, good detail, you may be able to just skip this step. And then you want to select a known quality photo ready material, a material that is known to produce a good photograph. And as you become more and more of an expert in engraving photos, you can kind of manipulate settings and you can get some photographs into some strange materials. There's really no limit. I mean, I've etched photos on chocolates and candies and seeds and rocks picked off the ground. I've actually etched a photo onto a seed through the seed pod at one point into the husk of the seed, stuck it in the ground, and then grew it so that the photo was on the first outer husk as it came out of the ground. So you can get crazy with photographs. It is possible, but it does require some skill. Once you have a photo ready material, you want to render that photo in engraving software, or if it's a good photo quality, you want to go directly through job control and just hit print on a sized and cropped image, you can run that photo directly using the preset filters in job control. Focus with the correct lens, Focus is very important. Not only the right lens is important, but making sure it's focused on the material. Something I really didn't cover when we were talking about the lenses, making sure your material is very flat. Make sure that it is a material that is consistently flat. If you have any warpage or variations or thickness difference on your piece of wood or acrylic or plastic, whatever you're running with, that can affect the photo quality because as you deviate from focus, or if the material is not perfectly flat, then what's going to happen is the focus is going to change. As I showed you earlier with the kind of divergence of the laser beam, the focus going in and out, as it changes, your quality can change. So focus is important, as important as the lens itself. And then, of course, using the right parameters. A little bit of trial and error, turn on photo optimized in our driver, in the job control driver, and then engrave that photograph. One trick that I use too, if I'm engraving a plaque, and instead of making the photograph crop to, say, 5 by 7, to engrave on a 5 by 7 plaque, I will always crop my photo slightly larger. So if it's going to be on a 5 by 7 plaque, I will crop my photo to say 5.1 by 7.1. This gives me a little bit of bleed, so I don't have to try to get it just perfect. This is a pro tip that I've made many mistakes not doing. Little things like that, making sure your photo is good quality. Again, cropping and repairing it, understanding photo quality and the difference between a bad photo and a good photo, the right kind of material, the correct lens, using the correct parameters, using the correct softwares, and then engraving those photographs with confidence. That is the tips and tricks for doing photographs with a laser. I know some of it can be complicated, so start with the basics, start with a good photograph, use the direct to engraving through job control, and then slowly add maybe some editing software. If you really get into the software, you may go with the third party softwares, which take some of the complexity away from it. Learn the parameters, and so stick with the material or maybe a settings that you already know or work really well and play with them a little bit. And then engrave that photo with confidence. And by doing so, you're going to be able to get phenomenal engraving quality onto all sorts of different materials. Like I said, from candy to chocolate to wood to plastic to metals to stones, any kind of material you can imagine. And that is our seminar for today. I thank you so much for taking a look at this seminar. Have a great day and let us know if you have any questions.